Hello friends and my dear students, as we are studying this building process which is metal joining process, today we will discuss about gas flame process which is also called as oxyacetylene welding process or oxy-fuel gas welding. This is used for the welding as well as cutting and straightening of any kind of work, that is metal. So what is this oxy-fuel gas welding? This is heat source is a flame produced by combination of fuel gas and oxygen. Fuel gas, it is some, in most of the cases it is acetylene. Okay, so oxy-fuel welding has largely been replaced by other processes, but it is still popular because of its portability in the nature. Means you can do your on-site job as well with the help of this kind of building, and low capital investment because you just need some two cylinder and welding torch, which is a very primary or very cheap process as per the concern of your capital investment. Acetylene is the principal fuel gas employed, means in most of the cases they are going to use acetylene. Now let's see what kind of reactions which occur during the welding or cutting of this oxy-fuel gas welding. Basically, combustion of oxygen and acetylene, which is C2H2, in a welding torch produces a temperature in two-stage reaction. Means there will be two-stage reaction as chemical reaction will form whenever you will mix or do the combustion or ignite oxygen and acetylene in a single welding torch. Okay, they will mix at a certain temperature. Okay, now in the first stage, this acetylene mixed with the oxygen and converted into two CO, two molecules of CO and hydrogen as well as heat. This reaction occurs near the tip of the torch, so it will produce some kind of color in the flame. In the second stage of combustion, this CO and H2 and occurs just beyond the first combustion zone. So in this part, this CO mixed with the O2 and it will produce CO2 and heat, and hydrogen mixed with O2 that will produce H2, which is water and heat. Oxygen for the secondary reaction is obtained from the atmosphere. Okay, secondary reaction means for the secondary reaction, this oxygen can be obtained from the atmosphere. This is your tip, as you can see here. This is a welding torch. This is tip. This is mixture where you are going to mix. One side is oxygen control unit, fuel gas, means another side is for the fuel gas control ball. These are the two balls to control the flow rate of oxygen control and fuel gas. Okay, so in this way you are controlling the flow rate and mixing here in the mixer, and then at the tip it is going to ignite. Now there are basically three types of gases you will get, three types of flames you can obtain by varying the flow rate of oxygen and acetylene, or the mixing proportion of oxygen and acetylene. Now what are those three flames? If the ratio is about 1:1 to 1.15 to 1, okay, then all the reaction carried to the completion and neutral flame will be produced. Means if the ratio of oxygen and acetylene is this much, or ratio of oxygen and fuel gas is 1:1 or 1.15:1, then it will be called as neutral flame. Most welding is done with the neutral flame, since it will have very least chemical effect on the heated metal. Means it will not change the properties of the metal you are going to heat or you are going to weld. So that's why it is going to be very effective. And as you can see in the picture, the inert white cone, it is the temperature of the inert white cone is roughly about 3100 degrees centigrade, and while outer blue flame, it will having the temperature of 1275, means 1275 degrees centigrade. At the torch tip it is 3100. At the outer side where you are taking the oxygen from the atmosphere, the temperature is 1275 degree C. Next, move towards the another type of flame. If you are taking the higher ratio of oxygen and fuel gas, which is 1.5 to 1, it produces an oxidizing flame hotter than the neutral flame, about 33 degrees centigrade. Means at the torch tip the temperature is roughly about 33 degrees centigrade, which is way higher than the neutral flame. So if ratio is 1.5 to 1, which produces an oxidizing flame, means this kind of flame is called as oxidizing flame, hotter than the neutral flame as I discussed, but similar in appearance. Means appearance is roughly about similar, as you can see in the picture as well. This is used when welding copper and copper alloys, okay, but harmful when welding because excess oxygen reacts with the carbon and decarburizing the region around the weld. Means decarburization will occur whenever you will use this kind of build. So basically use only for the copper and copper alloys. Okay. Now moving toward the another type of your building or build your flame. Okay, so that flame is called as you have discussed before, that is called as carburizing. Okay, this is oxidizing, this is neutral, and then the last third one is carburizing. So in this type, excess fuel on the other hand produces a carburizing flame. The excess fuel decomposes to carbon and hydrogen, and the flame temperature is not as great, about 3000, means at a torch tip it is roughly about 2900 degrees C, and there is an intermediate cone feather or intermediate feather will be there. Okay, and the mixture of acetylene and oxy-fuel, which is called as your fuel gas. So this mixture will be there in the torch, and flame of this type used the building Mondal. Okay, which is called as nickel copper alloys, high carbon steel, and some alloy steel for applying sometimes of hard facing material. Okay, so this is suitable for your monal material, high carbon steel, and some alloy steel. Let's see what kinds of metals are suitable for different kinds of flames. Means if you are going to build or using oxyacetylene building, then in mild steel you have to use neutral flame. In high carbon steel you have to use R, which is another your type. Okay, now gray cast iron, which is neutral, alloy steel neutral. So in this way you can use your types of flame, which kind of flame you have to use for different kinds of material. So I'm stopping here. So meanwhile, just subscribe this YouTube channel of Engineering College Banswara for more such content in different branches of engineering domain, like computer science engineering, mechanical engineering, civil engineering, electrical engineering. Okay, so stay tuned and thank you for your patience listening. Thank you.